Hello guys, welcome to our first ever YouTube and video recording. I feel very awkward about doing this because it seems like I'm talking to a camera and no one is responding. So I don't know, I'm not used to this, but I'm going to try to be simple with all of the things I'm going to talk about today. Uh, these things I have to explain are the previous activities that I've sent you for the past couple of days, and I don't want to move on to the new lessons if I wouldn't be able to explain the last two lessons that we did, that you, answered. So let's get started. So this is about inquiry 1.3 to 1.4. 1.3 was the activity you sent last Friday, and 1.4, I don't know, 1.3 was your homework, and 1.4 was the activity you sent last Friday. I will also discuss the work that you did yesterday. All right. So the question in 1.3, come on, fly. The question 1.3 says, is asking us why is it that most of the quarries are facing northwards or towards the north. So the reason is that it is the sun's the angle of the sun that makes the slopes face towards the north. The north face of a mountain may get less sunlight, which tends to be cooler. So imagine the mountain with the other side having more sun and the other side having less sun. So the side with the less sun will tend to be cooler, and when that happens, there'll be more snow and ice will deposit, and it makes it heavier, and then glaciers will start to move and erosion will start to happen. And this is true in the northern hemisphere, but if you go to the southern hemisphere, it's a totally different thing. It's the opposite way. Now here's a photo of an example of quarries and slopes created by glaciers. So the other side of this mountain will be the southern part, or the one that's facing or getting more sunlight, while the other area here has less sunlight, causing to get more ice and deposit and create heavier glaciers. As you can see, as it becomes heavy, it erodes this part of the mountain. So if you could remember the other landforms that we discussed last time, this will be your quarry or the bowl-shaped area. This very narrow and sharp edge of the mountain will be your aretes, and then the tip with several sides with adjacent quarries will be the pyramidal peak. Right, so if you could imagine again, the other side of this will be the southern side, getting more sunlight, and this area will be the northern one, which is facing the northern pole, the North Pole. If you go towards the southern hemisphere, then this will be the north and this will be the south. Okay? So as I mentioned a while ago, what happens to the southern hemisphere? So the cores in the southern hemisphere has the opposite. Same reasons apply. So most of their quarries will be facing southwards, and the northern areas will have more sunlight. So most of the slopes will be looking or be facing south. And but this is only generally seen along the mid-latitudes. So what do I mean with the mid-latitudes? So we have latitudes, or the angles from the equator going north and south. So as you go lower to the south and as you go higher to the north, the angle is increasing. So when we say mid-latitude, so it's between the latitude or the equator and the North Pole. So it's just in between those areas. Like this one. when you say mid-latitude areas, this is what I'm talking about with the arrows here. So this is your equator, this is your North Pole, this is the South Pole, and these areas with the certain angle of the sun's light will cause the cories to form. So in this area here in the northern part, most of the cories will form and face towards the northern area. In the southern hemisphere, most of the cories will be facing towards the southern area. Now what about here in the middle or in the equator, or the one in the north and south poles? So a different story applies there. In the equator or the equatorial areas, the slopes are getting getting equal amounts of sun. Okay, again, it's getting a direct hit, or the sunlight's angle is directly hitting on top of a mountain. That means all of the faces of a mountain will be getting the same amount of sunlight. While in the polar areas like the north and south poles, North Pole being the Arctic Circle and the South Pole as the Antarctic area, they are getting low amount of sunlight. So the slopes are getting very low amount of sun. So in short, places like the equatorial and the polar areas, cories may form at any side of the mountain. So the possibility of having a quarry is depending on how heavy that portion of ice in that face of a mountain. But if you are somewhere between or in the mid-latitude areas, then the one with the lower temperature or the one that's getting less sunlight will have quarries or have that erosion happening. Okay. So let's move on to other landforms created by glaciers. Okay, so this is one of your homework or the activity that you did last time. So check if your answers are correct. So we have glacial erosion like troughs, ribbon lakes, and hanging valleys. While deposition, we have the erratics and the moraines or the drumlins. So if you had this correctly on the last activity that we had, then you get 5 points. Most of you got 4, I think so. Okay, so troughs or the U-shaped valleys. If you could imagine this photo being in the glacial period, this is filled with ice, and then ice would move down. And right now, because we are in the interglacial period, there is no ice right now, and the ice has already melted, leaving this very smooth curve like a U-shaped valley. Right? And when the ice would melt, then we will have a river probably in between with lakes like this, which is what we call a ribbon lake. So ribbon lakes are very narrow lakes that are created by glaciers moving. So the reason why this is happening is because this area here is created by softer soil or land, while the areas on the tip of the lake may have a harder or less eroded land. So that means this area is now deeper because of the erosion of the softer rocks, while here doesn't have much space being eroded, so it remains to be intact. So again, harder rocks, softer rocks being eroded, leaving a very deep part where water can be deposited. So it is now a lake. And another one, we have the hanging valleys. So this is quite strange because in this photo you will see that there is not much ice. But again, because we are now in the interglacial period, which means there is not much, or the temperature is not that low to cover much of the surface of the earth with ice. So this, many years ago, if you could imagine, is filled with ice where water or ice would be flowing out of the ocean. And just imagine a hanging valley. It's like a sliced trough. So if you slice this, and then the ocean at the bottom, you may get something like this. So it's U-shaped, and there probably is a river in between or a lake somewhere there, and it's being poured out into an ocean or a river. So this is the hanging valley. The next two will be caused by deposition. So these erratics or large boulders of rocks are just left behind. This has traveled many from great distances, being sent or carried out by glaciers during the glacial period. So if ever in the future that we have a glacial period again, it will be filled with ice and it will be moving again probably to another mile or whatever. But it would take millions of years for this to happen. So erratics are big boulders deposited by glaciers. Oops, arrows. And last one, we have the moraines or drumlins. So these are smaller pieces of pebbles and rocks that are deposited. It could be under the glacier or it could be at the sides of the glaciers. So in this photo, they look like sand, but if you are really there, it could be like larger pieces of rocks that has been set aside by the flowing glacier. And at the bottom, if this would melt in the future, we'll see a deposition of smaller rocks. So moraines or drumlins are deposition of these rocks and debris from glacial erosion. So drumlins and moraines are created by deposition. Okay. All right, now let's move on to the next lesson, which is Enquiry 2 on thin ice. So it's like Enquiry 1 and Enquiry 2 will be somehow together, will be related because they will be talking about, they are talking about ice. But in Enquiry 2, this is more of the area in the northern pole, which is the Arctic Circle. And this was the activity that you created yesterday. All right, so this is the Arctic. And it looks very different from the usual map that we see, mainly because we get used to a type of map wherein it's laid flat with the Arctic on top and then the Antarctic at the bottom. So this one is still in a spherical shape, and if you look at the top of the globe, this is something that you might see. We have here Greenland, we have here Canada, this is Alaska here, this is the Eurasian plate or the top part of Russia. We have Sweden, Finland, and Norway here, and of course Greenland, and the whole Arctic Ocean. So the Arctic is a polar region located on the northern part. So again, this is dominantly covered by water. So the Arctic consists of the Arctic Ocean, which is the predominant body of water there, with some smaller seas, and parts of Alaska from the USA. You have Finland, Greenland, Denmark, Iceland, the northern Canada, Norway. We have Russia and Sweden. So all of these places and countries are connected and is located along the Arctic Circle. Talking about the temperature there, It's cold. It is negative 40 degrees during winter, and in summers it could be around 10 degrees. It's somehow melting. The ice are somehow melting because it's not 0 degree, it's 10 degrees. The lowest temperature recorded by far is negative 68. I could not imagine living in a place like this. I literally almost had nosebleed at around 7 degrees way back. So probably a negative will somehow make me a frozen mummy or something. And talking about the Arctic Ocean, again, the Arctic area is not a landmass. It is predominantly covered by water or floating ice because of the too low of a temperature. The ice would be floating around during winter, being blown by wind, and during summer, some of these ice will get melted. And there are also people living there. There are at least 4 million indigenous people living along the Arctic Circle. When you say indigenous people, there are like tribes or people who has been there for, or groups of people who live in these areas for a very long time already. It could be generations and after generations of tribes or local people who lived in there. These people are adapted into these extreme temperatures. So you know that part of being a human being is adapting to different types of situation or conditions where you live, similar to animals and plants. If you are not adapting, then the chances are you will not be able to survive. Adaptation is a way for people to actually, or living things to actually survive. So yes, people in the Arctic Circle have adapted to these extreme temperatures and conditions. Okay? All right, so I'd like you to acknowledge our lesson today. I'm not going to ask you to answer something, but here's what you need to do. I just want to make sure that you listen and watch this video throughout until the end. And I'd like you to get a glass or a mug and go to your fridge and put some ice in it, or a drink that you like. Could be Coke, milk, coffee, whatever. Sip and take a selfie and send it to me in ThinkWave. Creativity is very important, so your selfie somehow right now is gonna help you get some more points. So I don't know, let's see. So thank you very much for listening, and I hope that you will stay in tuned for the next videos I'm going to create. And have a great week. See you on Thursday.